This presentation video is on my gold claims called the Fry McVean Claims in Northwestern Ontario. I have two websites which are listed here, and my organization is called Gold Claims for Option. I'm a PhD geologist and a member of the PGO in Ontario. The second image is a map of the eastern part of Uchi Belt in northwestern Ontario. On the top right corner is the Pickle Lake town and three gold mines forming the Pickle Lake camp. These are the Central Patricia, the Pickle Crow, and the Donna Lake mines. To the southwest are the three claims in white labels, and these are my claims. One is Don's Lake, the central one is Fry McVean, and the eastern one is the Dempster Gold Claims. 11 miles north of the Fry McVean claims is the Golden Patricia mine. The green area is metavolcanic greenstone belts that host the gold deposits. This is the Fry McVean gold claims with a 3,200 meter or 2 mile long gold target. And this target is defined by 314 anomalous gold indicator soil elements in humus. It has also 28 very white VLF-EM conductors and with current density anomalies that are 50 to 100 meters wide. And it has a 8.5 mile long dilational radial shear zone. These are the kind that open up and are great hosts for gold. And my 2 mile long target is within this radial shear zone. This is a map of Uchi subprovince, the central part that goes from Red Lake on the left over to the eastern greenstone belt that shows the Fry McVean gold claims as a red arrow. The green is the gold-bearing greenstone belts, and all of the black dots are gold occurrences. If you look carefully, you can find the producing gold mines and past producing gold mines on this map. This is a map of the prolific Uchi subprovince again that extends further to the east and west. It goes from the Pickle Lake gold camp on the northeast with 3.5 million ounces to the Red Lake gold camp in Ontario on the west, and then further to the west in Manitoba, the Bisset gold camp. The Red Lake gold camp has produced about 41 million ounces, and the whole camp has produced about 50.5 million ounces, the whole Uchi belt. If we add the new Great Bear gold discovery at Red Lake and assume it has 20 million ounces, that would bring the total endowment of this belt to 170 million ounces, which puts it on the same level as the Timmins gold camp. This is a map of my 2 mile long anomalous gold target or corridor that extends on the left from Linjog Lake to on the right to Unnamed Lake. So we call the pink shear zone that runs through it on the southern side of this map the Linjog Lake Unnamed Lake shear zone. And it's this shear zone that contains the gold anomalies, of which there are 57 or 58 in humus, and also the gold indicator anomalies that are related, which are 90 iron, 63 molybdenum, 22 arsenic, and 32 antimony anomalies. On the north side is the principal Fry McVean shear zone that extends about 30 kilometers to the west over to Fry Lake. This is an oblique image that shows in yellow columns the 58 gold in humus anomalies. On the left is Linjog Lake, on the right is Unnamed Lake, and the distance is about 2 miles. To the north, you'll see a red line, which is the Fry McVean shear zone. I'm jumping 20 miles to the west of the previous maps to my Don's Lake claims. And on my Don's Lake claims, you'll see this dark blue line, the northern one, and it's the Don's Lake shear zone. It extends on the northwest under Don's Lake, where a drill hole here, and you can read the assay, was 0.84 grams per ton over 3.4 meters true width. there are 5 drill holes with gold in the shear zone that we put down. And 2,000 meters to the west of that hole is another hole which is at 2.3 grams over 3.2 meters. So why isn't the gold in humus anomaly above this gold intersection 50 or 100 or 500 parts per billion gold? But it isn't. The gold anomaly in humus very close to this drill hole is at 4 parts per billion gold. So if we go by proportions, if we reduce 4 to 2 parts per billion, then the gold in the rock in the drill hole should be about half of this, and that would make it about 1.5 or 1.6 parts per billion gold. And this is typical of humus soil samples. We see this also at Hemlo, where the numbers are not large. This is a map of the same 2-mile-long Linjog Lake, unnamed lake, shear zone and gold anomaly. The gold anomalous values in humus are in the pink area, and they are shown as red squares. The sample lines are vertical lines, and this is part of a 1,087 humus sample survey that covered much larger extensive areas on the claims, and they were directed to covering these radial shear zones that were detected from electromagnetic EM anomalies. This is a map of the same 2-mile-long Linjog Lake, unnamed lake shear zone on the bottom. It's about 500 meters wide, and you will see the gold anomalies as red and blue squares. This is the Linjog Lake, unnamed lake shear zone, and then off to the right, you will see there's another shorter shear zone with 10 blue and red gold anomalies in humus that is called the second order shear. These two shears form a subparallel array of right-stepping radial shear zones that continue to the east as subparallel shear zones. And they extend east in a parallel manner to the northern shear zone, which is the Frye-McVeigh shear zone. Both radial shear zone extend from the Frye-McVeigh shear zone at a 16-degree acute angle, and this is typical of radial shears. They can extend anywhere from 10 to 20 degrees from the principal or primary shear zone. And these are known as great shear zones that open up to great depths to allow the hydrothermal solutions to come up and form gold deposits. So out of here in these two shear zones, we have 74 gold anomalies contained within the two shear zones, and another 10 up in the Frye-McVeigh for 84. The 74 gold anomalies form about 6% of the total 1,087 sample population that was taken across the claims. The Frye-McVeigh itself contains about 5.3%, not the Frye-McVeigh, but Linjog Lake, unnamed lake, 2-mile shear zone contains about 5.3% of the total population. This shows a humus soil profile taken on line 56, which is on the western end of Linjog Lake, and it's the most northern north-south lines for the humus survey shown on the previous image. This is the most western. The anomaly shows a 6-part per billion gold peak. It's at the yellow peak at one sample station, and that would cover 108 feet. And together you get a whole chevron group of gold indicator elements, starting at the top with anomalous arsenic in blue, and then below it are anomalous antimony in pink, and below that anomalous iron in orange and anomalous molybdenum in green. These are the same anomalous elements that are found over the Hemlo Page Williams deposit by the Ontario government and by Gleason and Sheehan in 2 humus surveys. This is line 76, which is 2,000 meters to the east of the previous image on line 56, and it's just to the west of Unnamed Lake. Here we have 3 yellow peaks that define 3 anomalous gold sample stations, and these together extend over 432 feet. This sample area has corresponding anomalous arsenic in blue, antimony in pink, iron in orange, and molybdenum in green. So it's the same type of anomalous association that we find right across the 2-mile gold target. There are 28 such profiles like this, which I can send you in a PowerPoint if you are interested. And this is the basis of part of our gold target. The rest is geophysics. This is an enlargement of the previous map that you saw with these vertical lines and the blue and red gold anomalies on the Linjog Lake unnamed lake shear zone. To the north is the Fry-McVean shear zone. On the Fry-McVean shear zone, you'll notice a black dot. This is the Fry-Lake gold showing. And in the early 1980s, Major General Resources drilled several holes into the shear zone, and they generally got very low grade, less than 1 gram per ton gold in their drill holes at widths less than 1 meter. The best hole was a hole with visible gold that ran 24 grams per ton over half a meter. On this map, you'll see these very, very fine orange lines. These are VLF-EM Fraser conductors. These are the conductive zones which we interpret as smaller shear zones within the larger Linjog Lake unnamed lake shear zone. That is Rydell's within Rydell's. We think these are Rydell shear zones. And on them are very, very small dots, which are the current density anomalies, many 50 to 100 meters wide, but you can't see them here. We'll only see them in profile or in line section. The lines here are 11 lines on which Abitibi Geophysics ran their VLF-EM survey. This is a map, again, an enlargement of the unnamed lake VLF-EM survey that was shown previously. You can see the vertical sample lines, 100 meters intervals, the blue and red gold and humus anomalies, and again the fine orange lines which are Fraser VLF-EM conductors, and on them are the circles which are the current density anomalies. In both this map and the previous map, you'll see a very close correspondence between the gold anomalies and the Fraser VLF-EM conductors and the current density anomalies. These are essentially part and parcel of the same phenomena if we consider that the current density anomalies are probably caused by sulfide minerals, pyrite, arsenopyrite, molybdenite, and stibnite. And when these oxidize and dissociate, they create the elements, same elements, iron, gold, arsenic, molybdenum, antimony, and these are carried up through the roots and into the needles of spruce trees and come down onto the ground to form a 1 centimeter layer of humus, so that the humus gold is related to the sulfide minerals which cause the current density anomalies. So this close correspondence is a very good confirmation that we have a good gold target. And the survey only covers about half of the 3,200 meter length. We're talking about 1,700 meters. We saw before the humus soil geochemical profile at line 56. Now we're going to look at the current density profile from the VLF-EM survey. This is a north-south line. The right side is the north side, and the red are the current density anomalies. You'll notice on the left there's one current density anomaly that runs 6 parts per billion gold. This is the same one that you saw on the humus soil profile on line 56 with the associated gold indicator elements. To the right, extending under Linjog Lake, is a 100-meter wide current density anomaly that is a proposed drill target. This is a good, strong current density anomaly. This image is from a publication on the internet, and it shows the current density profile in India at the Padavura mine, gold mine. The gold mine has 2 red 100-meter wide, both 100-meter wide gold anomalies that are sitting right on the gold deposits. The report on this states that the anomalies are caused by sulfide minerals that are in the gold quartz veins. I'm showing this so that you can see that the previous 100-meter wide current density anomaly is very similar to these anomalies. And the next current density profile at Fry McVean that I will show will have a similar profile. This is another current density profile on line 61, which is 500 meters to the east at Linjog Lake from line 56. It's a very similar profile in that there are small anomalies on the left or south side, shown in red, and above it are two gold in soil anomalies at 3 parts per billion. I believe there are 3 anomalies in total, which you saw in the previous line profile of the geochemical survey. On the right side is a 75-meter wide current density anomaly, which is a good strong one that extends under Linjog Lake again. And these two anomalies that are 500 meters apart, the wide ones on lines 56 and 61, obviously correlate across the western end of Linjog Lake. This is a written summary of the ground VLFEM survey conducted in the winter of 2020. And what it is that the VLFEM survey was conducted over 17 lines over 1,700 meters strike length on the Linjog Lake Unnamed Lake Shear Zone. This is out of a total of 3,200 meters on the 2-mile gold target. The 28 current density anomalies showed very good correspondence with the gold geochemical anomalies on the Linjog Lake Unnamed Lake Shear Zone, and both are believed to be related to the same geochemical and geophysical phenomena. The targets on the proposed drill holes from the survey are 50 to 100 meters wide. Indeed, most of the anomalies are very wide. So 28 drill holes have been proposed or selected for diamond drilling based on these anomalies, and there are an additional 6 drill holes that are chosen directed to the gold in soil anomalies that have not been covered by the geophysics. This is a map of the proposed drill holes at Linjog Lake, and on the left you can see drill hole that is on line 56, and over to the middle on line 61 that can be joined together. And way over on the eastern side on line 69 is a conductor that is under Linjog Lake, so that these possibly are all connected across 1,300 meters. You can see there are probably 5 subparallel conductors that the drill holes are testing with CD anomalies. This is a hole on line 56, and it's a line profile of a proposed drill hole. And the 2 anomalies are shown as a projection downward onto the drill core, and they're shown in red. The azimuth and direction and length and position of the drill hole are all tabulated in a table which I can provide. The right CD anomaly at 100 meters wide extends under Linjog Lake partially. This is a line profile of line 61 showing a proposed drill hole. This is the same profile that you saw for the geochemical results and the geophysical results. I only show the northern anomaly, which is about 100 meters wide, projected downward to the drill hole. And this hole, again, would correlate with the hole on line 56, so that it's possible that over the 500 meters, one would want to drill holes across the western arm of Linjog Lake to test this. This is a map of Unnamed Lake with the proposed drill holes that intersect anomalies on at least 2 of the 4 VLFEM conductors. And these drill holes mostly are designed to test the long anomalies that extend under Unnamed Lake. This is a map of the 28 proposed drill holes that will test the 2-mile-long gold target and current density anomalies in particular at Linjog Lake and Unnamed Lake. And there will be an additional 6 drill holes, as I mentioned, that will test gold and inhumus anomalies. The pink dots on this map are the proposed drill holes into current density anomalies at Linjog Lake and at Unnamed Lake. This was sent in for proposed drill exploration permit, which is still pending with the Ontario Ministry. This is Ontario Geological Survey map P3588 that covers the Fry-McBean claims. You'll notice that there are 4 pink granite plutons that have arrows that point to them, and this is called a quadruple point junction. It's a very favorable feature of world-class gold deposits. The red dashed line is the Fry-McBean shear zone that goes 30 kilometers to the west. And the yellow dashed line is the Linjog Lake, Unnamed Lake shear zone over 5 miles or 8.5 kilometers, and the western 2.5 kilometers has not been yet explored. And the green is the mafic volcanic greenstone belt. I'm now going to talk about a paper that was put out by David Groves, a Western Australian geologist, who is a noted exploration geologist. And his paper is on the internet as referring to the structural geometry of world-class gold deposits. And if you read this paper, it's extremely interesting. What he describes are major gold deposits that are surrounded by 3 or 4 granite plutons, such as the pink ones that are shown on the previous map. And these are usually smaller size of stock size. And Fry-McBean is shown here as number 1 as a quadruple point junction because there are 4 of them. And to the west is Red Lake with about 33 million ounces in 6 mines, including the Campbell, Red Lake, and Kushner, that are within a quadruple point junction. I have a PowerPoint on this that I can send you. To the east of Fry Lake is under number 3 is the Pickle Lake Gold Camp with 3 mines. It's a triple point junction. And to the north, as number 4, is a Musselwhite mine with 6 million ounces. So Groves pointed out both the Red Lake and the Musselwhite mine as quadruple and triple point junctions, and I have researched to find the others. To the south on Lake Superior is the Hemlo Gold deposit of 24 million ounces. It's a quadruple point junction. And to the east is the Kirkland Lake as number 6, and the D-Turbonorm mine as number 7 as quadruple and triple point junctions. Over in Quebec, the Great Val-d'Or Camp with many mines is a quadruple point junction, and to the north, the Eleanor deposit is a triple point junction. Grove also describes a second feature of world-class gold deposits, and that is that they are found on second-order shear zones, which are like Rydell shear zones that extend at 10 to 25 degrees from the principal shear zones. And these are seen in Western Australia along the Boulder-Lefroy transcrustal fault, and one of them is the Great Golden Mile deposit that produced about 70 million ounces. Fry-McBean is one of these. Another one is the recent gold discovery in central Newfoundland by Newfound Gold with the Keats and Lotto deposits. These are spectacular discoveries that have caused a major staking rush and exploration in central Newfoundland that is going actively today. And these 2 deposits are on the same type of Rydell shear zones with the same geometry that we see on the Fry-McBean shear zone. They're subparallel right-stepping shear zones that extend from the principal Appleton Fault at a 20-degree angle. They have all the characteristics of Rydell, and that's why they're very wide and high grade. Don't hesitate to email me. I have many PowerPoints that cover special subjects. For instance, I have one on the Newfoundland discoveries, comparing it to Fry-McBean. I have another one on Rydell shear zones. I have one on the VLF-EM method, etc. And I have very extensive ones on the Fry-McBean gold target. Thank you for listening.